Strontium is a chemical element and a member of Group 2, or the group of alkaline earth metals in the periodic table. A radioactive isotope of strontium is not known to cause harm, but it is considered to be a potential health risk. This is because it is produced through a fission reaction of plutonium and uranium. A large amount of the radioactive isotope strontium-90 was released during the Chernobyl nuclear disaster. It forms red candle flames and is one of the most reactive alkaline earth metals. Strontium has 3 allotropic crystalline types. The most common is the cubic-centered structure. There are also hexagonal dense sphere packing and copper-type space group crystalline structures. The half-life of the isotope is very long. This makes it an ideal candidate for superficial radiotherapy. A study of strontium in human patients was conducted in the late 1940s. The study was carried out to evaluate the safety profile of this element. It is not a cheap or common element, and it can be contaminated by other compounds. Strontium was discovered in 1790 by Adair Crawford in Scotland. It was originally a mineral named strontia. In 1808, Sir Humphrey Davy isolated and purified it. During the 1970s, nuclear tests generated a radioactive isotope of strontium-90. This is a beta emitter with a half-life of 29 years. Strontium is an important element found in the Earth's crust. It is found naturally in many parts of the environment, including seawater. It is the 15th most abundant element on Earth. It occurs in various forms. In nature, it is found in many compartments of the environment. Strontium is present in the soil in relatively low concentrations. However, this element is known that some of it can migrate through the soil into groundwater. Well, this is not a good thing for humans. However, the production of strontium is not a threat to human health. This element is mainly concentrated in hydroxyapatite and occurs naturally in a number of minerals. Its major compounds are strontium carbonate. In nature, it occurs in marine fossils and in celestine, a sulfate mineral. Celestine is a valuable commercial source for strontium. It is also found in calcareous rocks. Strontium has a chemical similarity to calcium and will replace calcium as the mineral in bone. Because its atom is heavier than calcium atom, swapping some of the calcium atoms with strontium atoms will make the bone mineral density appear to increase. This is not the same as making new bone. A special form of strontium called strontium ranelate can increase bone formation and prevent bone loss when used in postmenopausal women with osteoporosis. When it is submerged in water, it produces hydrogen gas. The ionic radius of strontium is similar to that of calcium. As such, it reacts with calcium to increase the excretion of calcium from the kidneys. This element is similar to calcium and sulfur in its properties. Unlike calcium, it does not form a solid but rather a liquid. Strontium has a much higher affinity for nitrogen. The atoms of strontium are much larger than the atoms of calcium. It also reacts with air to form a pale yellow film on the element. Its optical dispersion is greater than that of diamond, and it is readily scratched. Although it is a soft bright silvery metal and it can be cut using a knife. Strontium is used in a number of ways. For example, it can be used to make permanent ceramic magnets. Luminescent paints and other electronic devices also use strontium. It is also used to produce electricity for space vehicles and navigation buoys. Some of the radioactive isotopes of this metal are used in cancer therapy and bone cancer. Strontium compounds are used in fireworks yielding deep red color. They are also used to make luminous paints, as well as phosphors for electroluminescent devices. It is rarely used due to its higher cost. In addition, strontium carbonate is becoming less and less important as flat panel technologies come into use. This alkaline earth metal is an effective oxidizer and is sometimes used in hair bleaching products. Additionally, it is a useful alloying agent for magnesium. Added strontium in Mg alloys can improve creep resistance, ductility, and the distribution of alloying elements. Some of the most common applications of strontium are in fireworks, in the refining of zinc, and in the production of ferrite magnets. Besides these, this element is often added to glass to prevent the emission of X-rays from television picture tubes. Last but not least, it is also used in glass screens of color televisions and in toothpastes for sensitive teeth.